Okay, so what we're going to do in this video is look at how a light bulb changes how it behaves as we apply bigger and smaller and negative potential differences across it. So in terms of the setup we've got here, we've got a variable resistor that's going to allow us to change the current and the potential difference in the circuit. That is in series with this light bulb. That is then in series with this ammeter that we've got here. And then there's a voltmeter in parallel with the light bulb, so we're measuring the potential difference across that light bulb. So let's just quickly sketch our circuit diagram for this so we can see what we're working with. So we've got a power pack. So this is our symbol for our power pack. We've got that going to a variable resistor, allows us to change the current and potential difference across our light bulb. There is our filament bulb there. That is then in series with an ammeter like this. And we've got our voltmeter across it. And using these two, we're going to be able to calculate what the resistance is by doing V over I. So we're going to look at how the resistance of the light bulb changes as we apply bigger and smaller potential differences across it. So in terms of what we're going to record, we're going to record two things from the experiment. The current we can see if we look at our ammeter, let's bring that across, is going to be recording in milliamps. So I'm going to record that in my table. And the resistance we're going to calculate in ohms. Okay, so that's our experiment. So at the moment I've got my variable resistor on its lowest resistance setting. So this is going to give us our biggest current and our biggest potential difference across here. I've already been through the process of trying to find what the best shunt is. So I tried the 5 amp first of all. Current was way too small. Same with the 1 amp. So I've switched down to this one, which is the next one I have available to me. So with this one, because this is a number that starts with 1, we're going to read on the scale that goes up to 10. The biggest reading we can do on this setting is 100 milliamps. So 10 on the scale is 100 milliamps. So let's say 4 on the scale is actually 40 milliamps. So we're going to essentially multiply whatever the scale reading is by 10. So our first current reading, I'm going to let that settle. So I'd say that's 8.5. So that's 85 milliamps. And the potential difference reading we've got there, that's settled on 8.33. Okay, so let's calculate our resistance. So we're going to do 8.33 divided by 85. We've got to divide that by 1,000 because that's currently in milliamps. So you can see that comes out as 98 there. Okay, so let's crank up our potential, well, our rheostat if you like. So it's now got bigger resistance. Okay, so that's sort of like midway-ish on there. So potential difference, that seems to have settled on 6.72. Our current, if we look at it, seems to have settled on, I'd say, 7.6. So that's 76 milliamps. So let's do our calculation. So we've got 6.72 divided by 76 divided by 1,000. So you can see that's now come down to 88. So it was 98. It's now come down to 88. Let's crack this up all the way. Okay, so our potential difference is now 5. Let's wait for it, see if it's going to settle. As soon as we're settled on 5.94. Current seems to have settled on, I would say, 7.1. So that's 71 milliamps. So again, do our calculation, 5.94 divided by 71 divided by 1,000. That seems to have gone down to 84. So it seems like for our smaller potential differences, we seem to be getting, the resistance seems to be coming down and getting smaller there. Okay? So what we're going to try now is some negative potential differences. So the way we do that is I'm just going to switch these two round on here. We're now essentially applying the potential difference in the other direction, which you can see means the current is now in the other direction. So So we're now applying a negative potential difference and we're getting a negative current. So I'm just going to switch these two round to give us a bigger range, but remember that our current is now negative. So on this setting here, we can see our current, that's about 7.2 on the scale. So that's minus 72 milliamps. Potential difference is flickering around, it seems to be flicking around 5.90. So I'm going to put minus 5.90. Don't have to be crazy about it. So we're going to go minus 5.90 divided by minus 72 divided by 1,000. And we see we've got 82. Let's now drop our resistance down somewhere to see what's going to happen in our circuit. Okay, so potential difference is now minus 7.30. So it's getting bigger but also negative. Current reading, that seems to be 7.8, so that's minus 78 milliamps. So I'm going to do minus 7.30 divided by minus 78 divided by 1,000. And it's jumped to 94. You'll notice the resistance is always coming out as a positive number, which is exactly what we should see. Resistance can't be negative, that's not possible. Let's drop this resistance to its lowest setting. Okay, so potential difference seems to have settled on minus 8.224. Our current is, I'll just read this out to you, so it's about 8.2 on the scale, so that's minus 82 milliamps. So we're going to do minus 8.24 divided by minus 82 divided by 1,000 gives us, that's going to round to 100. So if we see this, even when our potential difference is negative, we see that as we make the potential difference a bigger number, our resistance seems to get bigger here. So if we were to plot these as a graph, let's chuck this piece of paper so we can sketch it. Again, just like for the fixed resistor, we plot what are called IV graphs. That's just done by convention, doing an IV graph. So a filament bulb, what you tend to get is something that looks like this. So in this middle section here, it's roughly a straight line. Okay? So in this middle section here, it behaves quite like a fixed resistor. The resistance stays pretty much the same. Here, we've got a higher resistance. And it's the same thing here. We've got higher resistance over here. So that's what we can see on our graph. So this is what we call the IV graph of a filament bulb. We get high resistance here, high resistance there, pretty much fixed lower resistance in here in the middle. And this is a lot to do with temperature. So with the higher potential differences in currents, the light bulb is hotter, which is how we explain the fact its resistance is bigger. And it doesn't matter which way we have the high current, the hotter it gets, the bigger its resistance tends to get. So our filament bulb's temperature tends to change quite a bit when we're playing around within a circuit, which is what we should expect really, because the brightness of the bulb is essentially determined by its temperature, and the brighter it is, the higher temperature it's going to be. That's how we've made it brighter. So that shouldn't be too unexpected, but that's our IV graph for our filament bulb.